Hello, today's video topic is adaptive or dynamic word boundaries. In one of the previous videos, I have already explained the word, white space, numeric, and ambiguous word boundaries. There are cases when the strings that we want to match as whole words actually come in as user-defined entries, the strings that we don't have control on. In these cases, it is very important to know if there are special characters, especially at the beginning and at the end of those entries. Please recall what word boundaries are. So these are positions before the first character in the string if the first character is a word character, or it's a position after the last character in the string if the last character is a word character, or between two characters in the string where one is a word character and the other is not a word character. Now let's have a look at our test cases. We want to match several words like hashtag, his head, df, dollar, string, C++ or C#. And we want to match them as whole words. In this case, words consist of both word characters, like letters or underscore, and non-word characters, like this pound symbol, or space, or dollar symbol, or plus. So what to do in this case? In this case, we can use the so-called adaptive or dynamic word boundaries. There are two possible ways to actually implement these boundaries. The first type of the adaptive or dynamic word boundary is a boundary when we only want to make sure there is a word boundary position on the left if the first character of our search phrase is a word character. So in this case, you can see that only this hashtag word starting with the hash symbol is not the entry that we are interested in. So here, his head, df, string, C++, and C# are the words that we want to make sure there is a word boundary right before them, because they all start with a word character. Here, letters. And that means we are using this construction here, word boundary, that is followed immediately with a word character. In case of hashtag here, that starts with a non-word character, we don't need to check if there is a word boundary right before it. That's why we have this alternative that matches a position that is not immediately followed with a word character. If there is a non-word character immediately on the right, we don't check for anything. There is empty string here, as you see. And here are some test cases here. You can see that we matched C# word. We matched hashtag that is located right after a word character, but we don't care. There could be a non-word character. Here is not matched, but df dollar string is matched. Look, if we add a word character like 2, it's a digit, and a digit is a word character. There is no match here. And his head is matched, but not this head or this header, etc. We can see the invalid cases are not matched correctly. Now, how we can achieve this using code? Here is a Python notebook that I prepared for this case. Here are words that we want to match as whole words, defined in the words list, and the test cases are assigned to no match in and match in lists. So let's run them. And here is a very important block. When our words are actually phrases, especially with white spaces in between the words inside them, we would need to sort the entries in the words list by length in the descending order. This is important because, if you remember, the order of alternatives in NFA regex always matters. The first alternative that matches wins, and the other alternatives on the right are not processed. They are not even checked at all. And that means we want to make sure that the longest alternative is placed to the left or before all the shorter alternatives. So in this case, this line ensures we get the longest matches in our alternative. So then we need to escape the words. We don't know what kind of special characters there can occur. That's why we want to make sure that the regex remains valid after we put the string into the regex object. So the re-escape in Python works the same as pattern quote in Java or preg quote in PHP and so on. And next we compile the pattern that contains our type 1 dynamic word boundary. And this is a re.I option that enables case-insensitive matching in Python. So if we run this, we'll see that we've got this list of keywords. We escaped them correctly. You see all special characters are escaped. A space is also a special character when you use the verbose mode. And here is the regex pattern that we have just compiled. Next, we want to see if there is any match in no match in a list, and we get false. So there is no match in this a list. And in this block we want to see if all regular expressions find a match in, and it's true. So all strings from match-in list match the current regex pattern. Let's come back to our regex fiddle. Now let's speak about the second type of the dynamic or adaptive word boundaries. This is the case when we want to make sure there is no word character right before a special character that is at the start of our keyword, or make sure that there is no word character after the last non-word character in our keyword. In this case, all we need to do is add a non-word boundary construct right before the negative lookahead that checks for a word character here, and add this construct here at the end that checks that there is no word character at the end of our keyword. So in this case, we introduce more restrictions. In this case, we make sure, for example, that if you want to match a mention, for example, at mail.com, and we have mail.com here, but we don't want to match it as part of an email like this. So in this case, a non-word boundary should be added to the dynamic or adaptive word boundary construct. If you want to see the pattern meaning, you can always check the explanation on the right here. You may read more about these issues if you follow the links in the further links section. And if you liked my video, please click like and subscribe to my channel if you haven't done it yet. Thank you for watching, and happy regexing!